Hello, and welcome to today's webinar. My name is Ken.
And I am John, and we are data analytics customer engineers from the Google Cloud team. In today's session, we're going to look at marketing analytics solutions on the Google Cloud platform.
We have prepared some great content for you. We'll help you get an overview of the current industry trend, how it impacts the way your first-party data is being collected and used, and how you can benefit from adopting a customer data platform solution.
We also have some great use cases and sample architectures to kickstart your journey. We will be demoing two solutions to show you how easy it is to get value from your data by leveraging the Google Cloud solutions. With that, I hope you enjoyed the show, and take it away, Ken.
Let's kick off our session today with a quick overview of the latest industry and customer context in order to answer the question why we need a customer data platform and why now. The digital advertising landscape is experiencing a significant paradigm shift in the last few years, where we observe multiple changes are being proposed and implemented, with the goal of becoming more privacy-aware and privacy-centric for the consumers. Regulatory changes such as GDPR in the EU and CCPA in the US have put emphasis in a higher standard for how personal data can be collected and used. Industry and technology changes follow swiftly to have clear plans to abandon some of the widely used traditional data collection methods, such as third-party cookies and identifiers. Consumers themselves, apart from becoming more privacy conscious, are also forming new habits of interacting with the products and brands across multiple touchpoints in their user journey, hence creating complex and unique challenges for enterprises to collect and process data in a meaningful way. If we take a closer look at the customer journey, the basics still remain. Making a shopping decision still starts with a trigger and ends with a purchase. But what has changed is that the journey is not so neat and linear anymore. What I mean by that is we are seeing less and less people going from search, discovery, to purchase in one single session. What happens in between the trigger and the purchase has drastically evolved in the past years, mainly because of digital and mobile channels bringing more experiential and functional choices to the customers, as well as the prolonged pandemic and mobility restrictions have disrupted some of the customers' established shopping behaviors. As a brand, you cannot prevent customers from trying new things, from making comparisons. But what you can do to drive acquisition, conversion, and loyalty more efficiently is to get closer to the customers, to anticipate their need, to elevate their expectations with the right product innovations. When it comes to understanding customers and their experience journey, and in the face of regulatory and industry changes, there's really no better way than making the best use of the facts and information that are already generated and captured every time a customer engages with us, right within our own system, the so-called first-party data. Remember, first-party data is customer data that we can collect with the right user consent. However, the challenge is that this information are often spread across many places: ad campaigns, CRM systems, customer service logs, website and app analytics, loyalty programs, and much more. Apart from the distributed nature of this data, they are also vastly different in terms of the data format, the ingestion volumes, and some data sources even have the requirement of real-time streaming. This means it can be hard to get a complete view of each consumer. So what solutions can we come up with? We need a centralized data platform that can turn our customer data into strategic assets. While the exact name and definition of this centralized platform is not very well defined, some might prefer to call it Customer Data Platform or CDP, some might call it Customer 360. It is important to recognize the functions and capabilities of the platform. First, it has to unify first-party customer data across marketing and other systems. Secondly, to analyze and enable the modelings of consumer behaviors. And last, turn this modeling of insight into actions by optimizing the timings and targeting of the communications with the customers. As one of the leading and trusted platforms by many companies when it comes to cloud and marketing solutions, Google strongly believes that it has a primary role to play in helping enterprise to adapt and prepare in this new era. In particular, Google has invested heavily in many privacy-centric capabilities across both Google Cloud and Google Marketing Platform. With Google Cloud, a key focus is a platform infrastructure that can support the first-party data strategy. This ensures that all the cloud products and services can comply with regulatory requirements from where the data is being encrypted and stored to securely transmitted across the network to how computation is provisioned and scaled up and down. And when it comes to analytics capabilities, cloud provides a comprehensive portfolio of solutions to help bring modeling, machine learning, and automations into building out the customer data platform. Combined with other privacy-preserving technologies across all the other Google platforms and products, enterprise can expect a strong partnership with Google in this journey. Next, let's deep dive into some of the key concepts and building blocks as we plan to implement the CDP on Google Cloud. And it's not just all about Google native services. There are probably two ways to start your CDP journey with Google Cloud. First is through our ISV partners. These are software as a service products that solve for specific use cases that fit within the CDP space. They come with pre-built components for user interfaces and automation, which can help you get to the values relatively quickly. The other route is building a custom solution leveraging various Google Cloud services. This is a design and build route that provides complete flexibility and control to decide your own roadmap and priority. It is fun and very easy to start small and then extend seamlessly into use cases beyond marketing too. These two options are also not mutually exclusive, as the custom-built CDP can also leverage additional functionality from our ISV partner solutions if needed. As a quick recap, the first step of your data journey is bringing data together from various data silos. Once all this data is collected together in a single place, we can analyze and visualize them to generate actionable insight. Then, you use this insight to create better experiences for customers and activate those insights across your organization. Let's now double-click into the how. Step 1, collect and transform. Among all the data sources that we potentially need to ingest into our CDP, many of them originate from Google ecosystem, like marketing and campaign data with ads and GMP, user interactions by Google Analytics or Firebase. Together with many popular SaaS solutions for your CRM or social media, they can all be collected to Google Cloud serverless data warehouse solution BigQuery using native connectors. Native connectors mean you don't have to worry about maintaining the resources, the schedules, and data pipelines. They are very easy to configure with just a few clicks. Outside of native connectors, for example, your on-prem data sources, Google Cloud also provides many options to collect and transform data. For the technical practitioners out there, even though there are many product logos being shown here, a key takeaway is you will only need to choose the option that best fits your data collection strategy. Like for streaming, you need to use PubSub. For batch, it will be cloud storage. It also depends on whether you prefer a graphical interface with drag and drop capability to construct your data pipeline like Data Prep, Data Fusion, or you prefer a programming approach with Dataproc for Spark or Dataflow for unified Apache Beam that handles both batch and stream. The destination of your data in this step is still BigQuery, as you are ready for the analysis. Let's talk about what we plan to do with the data once we have collected them in the centralized data warehouse. On one hand, we want to promote a healthy data culture across the organizations by facilitating self-service data visualization and exploration, and sharing of those results for quicker operations and actions to delight the end customers. On the other hand, we now increasingly have the ability to activate the power of AI and machine learning for a broader set of problems that traditionally require a lot of data engineering with minimum or no coding at all. In terms of toolings, while it is possible to connect BigQuery with any of the business intelligence tools like Google Data Studio, Tableau, or Power BI, Looker, goes beyond just beautiful reporting and dashboards by providing a semantic layer for consistent data definitions that can be very important for data governance, as well as its integrated data-driven workflow capabilities. John will cover more use cases involving Looker in the later part of today's session. Let's now switch gears a little bit to talk about AI and ML and what I meant by low-code or no-code option. When it comes to AI and machine learning, there are really three key elements that can influence a successful outcome. First, data. We need a lot of them, and it's how the machine learns by looking at a lot of examples. Algorithm, instructions on how to operate on the data to create model for specific outcomes like prediction or classification. And compute is the environment to execute those learning algorithms. Out of these three elements, we don't really have to worry much about the resources to run the computation in the cloud. But for the other two, we do have a few combinations of options. And that is how our AI portfolio is structured in Google Cloud in three different buckets. In the first bucket, we have the option that utilize both data and algorithm from Google itself. These are the pre-built models and solutions that are typically interact via the API calls and let Google take care of the heavy lifting. Examples include many natural language models like translation, speech-to-text or text-to-speech, or vision models to analyze images, documents, etc. We will typically leverage these models to extract meanings for our unstructured data and convert them into structured format for further analysis. Then, on the other side of the spectrum, there's option for us to build custom models from the complete ground up using our own data and our own algorithm. You will still benefit from the framework and best practices that the platform provides, but typically you need to have some extensive knowledge in this domain in order to design your own algorithms. But most of us may not have the expertise to take on this path, which brings us to the final option, where we can leverage Google algorithms on your own data. This is indeed an attractive option, as the models can now be created to address specific patterns in your own data, while we benefit from the well-established algorithms maintained by Google itself. This is the low-code or no-code option that I started talking a moment ago, with services like BigQuery ML and AutoML, and you will see them more in actions later in the demo session. Going back to our CDP journey, you are now ready to take these new insights and leverage them to improve your marketing with seamless activations, as well as customer experiences. For example, after forecasting what products individual customers might be interested in, we can provide them with personalized product recommendations. Or after predicting some of your high lifetime value customers are at risk of churn, you can automatically send them messages with a specific offer to encourage them to stay. Specific to the activation of your marketing outcomes, just like how you can access data directly from Google's suite of marketing products at the beginning, you can now complete the cycle by ingesting data back to these platforms to optimize your metrics like cost per click, return in ad spend, or to create audience segments for better customer match. And it's not just about technology. Together, our teams in Google Cloud and Google Ads have the right experiences to help you implement and deliver your vision. In summary, this is how everything comes together in this high-level architecture of a CDP. We can easily ingest and transform data from various sources, apply advanced techniques and analysis to understand and extract insight, and supercharge your various activation channels. In the next session, we'll be zooming into many of the common marketing analytics use cases to put theory into practices. So stay tuned.
Now we're going to look at some common marketing analytics use cases. First example could be marketing insights. This is where you actually gather more intelligence from your existing data analytics platforms or CRM platforms. Here you can actually look at your channel performance and make better predictions about what the users are going to do on your website. The other side is audience segmentation. Here you can leverage machine learning models to build custom segments right on BigQuery, or even do things like propensity analysis, where you calculate the probability of a user buying a certain item or taking a certain action, like churning from your website. Finally, You can leverage all this information to improve your customer experience. Things like improving your support channel based on what the users might need would be a great feeling for the user. Now we're going to look at some of these use cases in more detail and go over the architectures. For example, Looker is a great tool to analyze your existing user data on your marketing channels. To enable this, you would first import this data from Google Analytics, resources, or any CRM data or any other marketing platform that you gather on the users. This would all be gathered within BigQuery and then pushed back into Looker. Within Looker, you can run various types of analysis on these users and do custom segmentation, and you can visualize data across your organization. Another solution is attribution modeling using Fractribution. Some of you might already be aware of tools like data-driven attribution for Google Ads or Google Analytics. But it is possible to expand this use case leveraging Google Cloud Platform. The Fractribution solution uses an R package that runs on an existing VM platform. In this architecture, we are essentially ingesting data from web analytics platforms and CRM data, things that might relate to offline conversions, for example. We store this information on BigQuery and then run the Fractribution analysis using the VM models. This data then feeds back into BigQuery, where it can be analyzed using Data Studio or Looker platforms to analyze data in more detail. Another important solution is audience segmentation. This is actually one of the demos that we're going to run later on. Here, it is possible to ingest data from Google Analytics and existing CRM platforms to look at these audiences in more detail. Essentially, once we ingest the data into BigQuery, we can then run analysis either using the Vertex AI, as shown in this example, or we can also leverage BigQuery ML to create custom audience clusters. These audience clusters then can either be analyzed on Data Studio or Looker, or it can also be exported into a Google Cloud Storage bucket, which can then be pushed back into marketing activation channels. Again, during the activation section and in the demo section, we're going to get into more details of these use cases. Instant BQML is the easiest way to actually calculate propensity scores leveraging your existing web analytics data that works both with Google Analytics 360 and Google Analytics 4. It is essentially an application that runs on AppSpot, which you can easily enter your Google Cloud information and Google Analytics dataset information, which then automatically returns propensity scores of these users based on specific events that you might define within your BigQuery platform. Once we have the audience propensity scores based on Google Analytics data, we can store them into BigQuery and then activate them on marketing channels as you see fit your business. Then there's customer lifetime value. This helps you answer questions like how much revenue will a certain customer bring in if their first purchase is an X product, or how much value users bring in when they actually use a certain marketing channel. Essentially, you can use BigQuery ML or AutoML to create a list of profitable customers and assign this profitability to their specific marketing channels. In this architecture, for example, we're ingesting CRM data and Google Analytics data into a BigQuery repository, which we then analyze either using BigQuery ML or Vertex AI. Just like in the previous examples, these datasets then can be analyzed on Data Studio or Looker platforms, as well as being pushed into a Google Cloud Storage bucket to be activated on Google marketing platforms. The final use cases around customer experience. One of them is sentiment analysis. It is possible to analyze the comments that the user is leaving on your website or on YouTube channels or on Google My Business platforms, for example, to understand how they feel towards your products or towards your specific stores. For example, in this example that we have, it is possible to ingest Google My Business and YouTube comments into a Google Cloud Storage bucket using their native APIs. This dataset would then be pushed into Google BigQuery. Within BigQuery, it is possible to analyze it using the natural language processing API to understand what the users feel on specific videos or specific locations. As always, all this data can then be analyzed using Data Studio or Looker platforms, and these insights can be shared across your organization. The Google Cloud Platform can also be used to help you understand how certain creatives actually help certain actions. For example, it is possible to import your existing creatives from your marketing channels and then merge this with the datasets that you have on your performance analytics. Let's take a deeper look at this architecture. We have data coming in from your marketing platforms regarding your creative sources. and also coming in from your other marketing platforms to actually analyze your conversion process. Merging these two data sets, it is possible to understand what types of creatives are actually resulting in more conversions for your users. All this data that you store within the creative repository, for example, can be analyzed through Vision API or the Cloud Video Intelligence API to programmatically show you what kind of creatives lead to most conversions on your platforms. Now that we have the audience lists set out from the first section, it is important to understand how we're going to activate them on the marketing channels. Essentially, there are three ways that you can do this. One of them is leveraging a partner from the ecosystem. The other is building your own pipeline. And finally, leveraging Looker's activation blocks. For partners, two examples that you can leverage is Lytics and Bloomreach. Both of these companies provide a software as a service solution where you can easily ingest your data sets from BigQuery and push them back into the marketing channels. The companies take care of maintaining any APIs that require connecting to these marketing platforms and support a wide array of solutions like Google Ads or any email advertising solution that you might want to actually leverage. If you want to do the DIY way, it is important to understand that Google Cloud Platform does not have any native activation channels into ads platforms. You would have to build these leveraging Google Cloud's own modules to actually build the pipeline to push the data into the marketing platforms. The data activation is done through various APIs that these marketing engines have, things like customer match or conversion measurement for Google Analytics and various other APIs. There are some open source solutions like Megalista, Modem, and Tentacles that you can be used as a kicking off point to actually build your own pipeline. Let's take Tentacles, for example. This is the platform that we're going to leverage in the demo later on as well. So quickly give a highlight of what components we'll be using. First, we'll be using Cloud Functions, Google's service solution to actually build the event-driven application, and PubSub, which essentially provides pushing of messages and files back and forth in the server, and then cloud storage to store the audience and serve as a trigger point for the audience lists. To briefly look at the architecture of Tentacles, essentially what we're doing is setting up a cloud function to keep an eye on a Google Cloud Storage bucket for any new files that are going to be imported. When it detects a certain file matching a certain file name format, it immediately understands what marketing channel this should be pushed into, and then activates a cascade of PubSub functions, which essentially takes the file from Google Cloud Storage Service and pushes it into the marketing channel, leveraging the relevant API that's being asked. And Tentacles supports Google Marketing Platform, Google Analytics, and Google Ads. It is important to note that all of these platforms might use different file formats and different data schemas when ingesting data. It is important that you are using the right file format and right schema for the right marketing channel. Again, we're going to use Tentacles during our demo later on, but you can also check out their GitHub page and this YouTube video that shows you how to get started. Looker allows you to have a single location where you can ingest data from your CRM and web analytics and any other marketing platform that you might want to ingest data into. Looker allows you to easily access and analyze your existing data sets and share the insights across the organization. But beyond this, and especially from the marketing analytics perspective, it is important to note that it has great benefits as well. For example, Looker can natively ingest data from BigQuery and many other cloud services as well. It can also ingest data from your existing CRM systems. But more importantly, it allows you to merge all this data on its platform and dig deep into the data to gather analysis. But beyond this, it also has pre-packaged blocks that can help you analyze the data and activate it on other channels as well. It is super easy to get started on Looker. First, you would have to identify the Looker blocks that fit with your use case and fit with your data sets. Out of the box, Looker has solutions that make it easy to analyze Google Analytics data, for example. Then comes the build section. Using these blocks, you can build your data analysis and visualization engine on top of Looker. But you can also do some filters to analyze the data and activate them on marketing channels as well. Here, Looker can look at any of the data that's already stored within BigQuery that you have created using any audience segmentation algorithms, for example. But also, Looker has activation blocks, which allows you to push this data into marketing platforms like Google Marketing Platform or Google Ads, as well as some other solutions that we're going to look at later on. But beyond these, if your marketing platform does not have a native Looker integration, it is possible to leverage Looker's API and webhooks to attach it as one of these action points as well. Now we will look into some demos. Ken will demo Instant BQML, where we create propensity scores based on Google Analytics data, and I will then take over and show you how a CRM data can be merged with Google Analytics data to create custom audience clusters that can then be pushed into Google Analytics leveraging tentacles.
Welcome to this demo session where we walk you through an end-to-end deployment of Instant BQML and build out a use case on how we can predict the customer propensity scores from Google Analytics data. Instant BQML is just a tiny web application developed by our friends at Google Ads. In fact, it's just a web form with a couple of fields to complete, as we will take a look shortly. It actually started off as an internal tool but has quickly gained traction, and thus eventually opened up the secret sauce to the public audience too. Instant BQML helps streamline the entire process of connecting the Google Analytics data, automatically building a custom machine learning pipeline with BigQuery ML, and hence the name, to predict the propensity score based on the chosen objective, and then sending the results back to Google Analytics itself. Speaking about the marketing objective, Instant BQML has recommended a few common options here for us to select, and the underlying machine learning model will then be tuned towards that objective. For example, purchase propensity and repeat purchase propensity are based on actual transactions that have happened, and you want to model the characteristic of those users who will most likely convert so that you can target them more effectively. Another objective might be to optimize based on the destination URL in your digital website. For instance, when there's a specific landing page, when the user decides to add a shipping information or credit card, it's very likely that they are about to complete a purchase. Now, let's look at the overall architecture of the system that we are going to deploy. On the left-hand side, after filling out the Instant BQML form, you will be able to download the generated instructions for the end-to-end process. You will then upload these instructions into another lightweight open source application from Google called CIMint that is responsible to interact with the actual Google Analytics and Google Cloud services to execute the given instructions, including all the data connectivity, formatting, and the ML models to calculate the propensity scores, and finally publish the results back with the custom audience definitions. There's just one more thing we need to check on before the deployment. Those are the prerequisites. It is expected that we have already set up the data export to BigQuery for our Universal Analytics data, GA360, or the new GA4 properties. The instruction to set this up is outside the scope of this demo, but these are ready steps to complete with just a few clicks. And typically, it will also take up to 24 hours for data to be available in BigQuery, so we need this to be ready before we attempt the deployment. Other resources that we need here for Google Cloud are obviously BigQuery, where we store and process the Google Analytics data, as well as the Google App Engine for us to host the CIMint application that we briefly mentioned earlier. We will also expect to have the right permissions to access Google Analytics data, as well as to interact with Google Cloud services. With that, let's get to our live demo walkthrough. The first thing we want to do over here is to head into our Google Analytics console to make sure that we have the prerequisite of our data exported into BigQuery. We can do this by getting into the admin section. Over here, we can check there's a BigQuery links section under product links. And over here, we actually can see we have already defined a BigQuery export into our project. You can further click into this to see the details of how we configure the link. A particular section we want to pay attention to over here is the frequency. It is how we want to export the data from Google Analytics into BigQuery. As a daily or streaming or both. There are three options. We can also validate information from our BigQuery site. So get to our Google Cloud console, get into BigQuery, and we can actually see the data set being created under our project. By clicking under the section over here, you can see there's a data set being created, and it has the name of our Google GA property as well, which is the name under the underscore. It will create a partition table for our daily export. So you can see this is 92 partitions in our data set. So it represents 92 days of data. We can look at the schema of the data and even preview them by clicking on the preview button. So these are the standard data format that we have captured and exported into BigQuery. So now we are ready to get into our instant BQML to start our deployment. Please pay attention that we are looking at the instant BQML for GA4 property. There are also another version, instant BQML for Universal Analytics, which is for the older version GA360. We recommend our user to follow the GA4 properties because the Universal Analytics or GA360 will be deprecated very soon. The first action we want to perform on this section here is to deploy our CRMin application. So we can actually do this by heading into our Cloud Console. By clicking on the more details, let's see what information we need to gather. Let's get back to the Cloud Console. We will do this by running a command in a Cloud Shell, and I can activate that by clicking on the button over here. The first step that we recommend the user is to always set the project ID to be the current project ID so that we won't mess up our deployment with any other projects that we have in our organization. So we can just copy this command over here together with the project ID. All right, let's run this command to set the project ID to the current project. And this is also the first step that BigQML asks us to do. Let's also maximize the screen. Now let's get back to instant BigQML form, and we will perform the second step here, which is to deploy the application itself. So it's just a command that we need to copy and then paste into our Cloud Shell. Let's do that. We'll copy and paste. All right, we are ready to execute this command by hitting the Enter button. It will just clone the script from the GitHub because this is an open source project from Google. It will download some of the prerequisites and then it will start the deployment. Okay, here it's asking us whether we want to include some anonymous statistic, which we're happy to provide. So we just provide yes in this case. Okay, now it started the deployment. So we will see you checking all the prerequisites, project ID. You also activate some of the services like App Engine and Cloud SQL if it hasn't been activated already. If you're running this for the very first time, you might also see the options for you to select the Google Cloud region for your App Engine deployment. Since we don't have time for the entire installation, I've already done it installation on the other project. And I'm going to switch over to that screen now. Okay, so you can see all the outputs similar to what you would be seeing if you would run it from the beginning. Over here at the end, you will notice we will get a URL, which is the link to our CRMin application. So you can click on the link to launch the application itself. And this is the interface. We will return to this screen later, but now let's continue our journey with instant BigQML form. For the rest of the instant BigQML form, it's more or less like a scavenger hunt, where we gather information from different places and put them together in this form. So first of all, we'll answer the question, what is the marketing objective we want to select for this deployment? So we have covered that in our session earlier. Over here, I'm going to stick with the event propensity, and I'm going to put in an event name called Add Shipping Info, which I've already created as part of my Google Analytics installation. The next question is going to ask is whether the project that we deploy the CRMin is the same project where we have our GA4 BigQuery export. Typically, this is the same project if we were to deploy this from scratch. But it's also possible to select different projects. Now, let's put in the Cloud Project ID from where we export our BigQuery information as well as our CRMin application. So we can head back to the Cloud Console to get the information. Let's first close off this Cloud Shell. We can go to the top left corner over here and click on the project list to gather the name, the project ID for our current project. So let's copy this string over here, and then we can paste it back into the instant BigQML form. Okay, let's do a paste. The next section, we need to get the dataset ID itself where we export the GA4 data into BigQuery. So this is just the name of our dataset. You can get the name by clicking on to the dataset to open up in the details page. And you can grab the session of the name after the dot. The pub before the dot is the same as the project name that we have just selected just now. So let's copy the dataset ID over here and paste it. Another session we need to get is where the data is located. You can export data in any locations, but in this case, I'm using US as my data location. So let's just copy US and provide that into the form. The last section over here related to BigQuery is how we want to segment our namespace. It's just a prefix that will be appended in front of all the models or the artifacts that we are going to create from running this pipeline. It's just a way for us to remember if we have multiple objectives running concurrently. So over here, I will just put a prefix called BigQML event propensity. And that's the last information we need to provide for BigQuery. The next section, we are going to get all the information from Google Analytics, and they are also color-coded in that case. They have different colors compared to the cloud section just now. The first section over here is to get the measurement ID from our Google Analytics. We can get that by going back to the console, and then under the data streams option, we'll be able to see we have set up one data stream as part of our GA4 installation. If you click into the details of this, we can see the measurement ID, which is right there. You can copy it directly by clicking on the button over there and paste into the form. Just in case you can't remember where to navigate in the console, there's also an option to click on the more details over here, and it will guide you through where you can find a particular information in this form. So let's close this off. And next, we need to get the Google Analytics API secret. Again, this is how you can get the information if you can remember. It's under the same session that we have opened up our web stream. If you go to the bottom over here, we see there's a measurement protocol API secret section, or you can go into that session and get our API secret. You can get the existing API secret, but for best practice, we normally will create a new one. In this case, for a quicker demo, I've just copied the existing one that I've created earlier. Okay, let's head back to our form and paste in our secret. Okay. The last question over here is how frequent we are exporting our BigQuery data, our GA4 data into BigQuery. And we have seen from the earlier session, it's a daily option that we have selected on configure for our current data. So we just pick the option over here as daily only. Once you complete all the questions here, you can see the two buttons light up, and you can now click on them to download your training and prediction pipeline. So let's do that. Okay, we download the two pipelines. These are the instructions provided by Instant BigQL form after we fill up all the details. And now we need to upload these instructions into CI/Mint to execute our pipeline. Okay, once they are downloaded, let's head back to CI/Mint application, and we can go to upload the template by clicking on this button, import by template. Okay, let's select the two pipelines. These are JSON files that we just downloaded from Instant BigQL. Okay, let's also upload the other one for the prediction pipeline. So you can see they have created two pipelines based on the instructions that we have provided. We can get into the details of each of them and take a look. This training pipeline only has one job, which is to build the BigQML model from the data that we have exported from GA4. You can further click on that to look at the details. Okay, so here we can see these are the syntax specific to BigQML for you to create the model. These are all the instructions that have been provided by our Google Ads friends, so you need to worry about that. And the model has been tested on many other scenarios. Let's head back to our pipelines and take a look at the prediction as well. So we can go back to the previous screen by clicking on the pipelines button. And now let's look at the prediction pipeline. Okay, over here for prediction, we have three jobs. It starts with predict action, which is going to take our instant BigQML model just now we have created and do the prediction on all our audience. Then it will format the score from that model in the second step. Let's go into the prediction step as well over here to look at what is happening. Again, these are specific BigQML syntax for prediction where we don't need to zoom into the details. Okay, the last step of this is to send the events back into GA4. Okay, so now let's kickstart our pipeline. There's option here for us to run the pipeline as a scheduled task. I mean, it can repeat the same activity days on every week, or you can just also run it as a one-off task. So for the purpose of this demo, I'm just going to run it as a one-off event. So you can click on the Run Pipeline button to kickstart this training pipeline. The pipeline itself will, as I mentioned, will build a BQML model under the hood. It will actually take 5 to 10 minutes for the model to complete. So we are not going to wait for this live demo. That's why I have actually built this model earlier, and I'm going to switch over to my other tab where I have just run the same pipeline. So over here is the same pipeline. Let's do a refresh to get the status of this pipeline. You can see that it has completed successfully. Let's also go back to the overall pipeline and take a look at the prediction pipeline. You can see from the status, it's also indicated as a success. So after we have completed both pipelines successfully, we can also look at the artifacts generated from within BigQuery. You can see there's a model created under our dataset called BQML event propensity model. You can click on that to look at more details of the models, how it's being trained, how it's being evaluated, and some of the schema information. But these are just for your curiosity. There's no need to worry about that for our particular demo. You notice that there are also 2 other tables being created as part of the prediction pipeline. You get your user ID and the prediction score for each of them, whether they will convert or not. And also another table that we actually format this data into the requirements needed by GA4. So you can see in a preview, pay attention to the event column where we have a post score event and the associating score where we are going to use that to create our custom audience within GA4. So this data has been posted back into GA4, and our last step is to create a custom audience. At the moment, there is no API to create custom audience within GA4 directly, so we need to do this step by hitting the console itself. So let's head back to the console. We can define our custom audience by going back to the configure option over here on the left panel. And then we can find the audience sessions. Over here, you can create your own custom audience. And what we typically do is to, based on the score that we just calculated, the propensity score, we can group users into buckets of different sizing. Best practice is to group them under decile of 10%, so that we can choose activate based on different buckets if we want to. So for example, in the decile one, I have actually created the conditions to select my top 10% audience. Okay, and as I mentioned, it's based on the post score that we have created just now in our final table in BigQuery. And the score is set to the top 10%, which is a range from 900 to 1,000. So we have seen how easy it is to turn your Google Analytics data into great insights with your custom audience definition. To measure the success of this custom audience, let's look at a case study. Toyota Canada wanted to ensure their campaigns were reaching the people most likely to convert on their site. They began exporting its first-party website data in Analytics 360 directly into BigQuery. Then the team used BQML to analyze and run models on the data. After analyzing a month's worth of data, the machine learning model assigned a propensity score to each visitor, indicating how likely they would be to return to the site within 30 days to complete a bill and price action. Then, using the integration between Analytics 360 and Display and Video 360, the team was able to share the audiences it had just created into Display and Video 360, which then delivered the display ads to reach those people. The new audiences identified by BigQuery outperformed Toyota Canada's previous strategy to re-engage website visitors more than 6 times over. At the same time, their cost per acquisition was reduced by 80%. In summary, you can start your own instant BQML journey today by visiting this URL. And we look forward to you achieving great success with your marketing objective.
So in this demo, we're going to look at how we can merge existing Google Analytics data and CRM data. We start by ingesting and creating some sample data. This code essentially ingests some data from the Google BigQuery public dataset that contains Google Analytics data. While it's ingesting, it's creating some product categories based on what the users have purchased on this website. We'll start running. And here we can see the data set that's created as a result of the algorithm. We have full visitor IDs and the different categories that the users have purchased products for and how much was spent on each of these product categories. We will then create some synthetic data. Normally, this is something that would be contained within the CRM system. But in this case, we're going to use the Google Analytics data to create something called household income, HHI. We will also ingest gender as M or F within the data set. We will then join these two tables together. Essentially, what these ingestion algorithms do is that they create different CRM tables, which we then merge by merging them on the full visitor ID that both these data sets contain. Once we have these tables joined, we can easily run a BQML means function to create 7 clusters based on the data set. And this BQML k-means 7 model will be stored within the BigQuery project. Here you can see some other models we've run before showing the outcome of all these different clusters. Once this model is created, it is also pretty easy to create a prediction. Essentially, what we will be doing is calling the MLPredict function using the k-means 7 model on our trained data set. But this isn't always as simple as this, right? We don't always know how many clusters would perform the best with our existing data set. In this example, we use 7, but we might want to actually get more insights. So in this case, we want to run multiple k-means clusters to determine which one has the best results. So we will use something called procedure within BigQuery. Essentially, what this procedure does is that it will create the framework for running these k-means models using different input. For example, in this case, if you put k-means 3, it would create a cluster of 3, 4, 5, etc. on the following pages. And all you would have to do would be to call this routine. This allows you to run multiple audience clustering algorithms with great ease. Once that's created, this will become a routine within BigQuery and is stored within the BigQuery project. And in order to train these multiple k-means models, you can call it multiple times within the single query, making it very easy to get your results. Once these models are created, it is important to also note to look at the evaluation metrics. So you want to know which ones are actually performing best. In order to do this programmatically, again, we will create a routine called evaluation metric. And this will take in 2 inputs, initial cluster and final cluster, which will increment the number of clusters while running through the loop one by one. So if you input evaluation metric 3, 9, it will run through the evaluation metric for k, 3, 4, 5, all the way to 9. So once we've actually created this evaluation metric and saved it in BigQuery, we just run it by call evaluation metric 3, 9. And this will create a table called evaluation metric. And if you want to analyze this, you can click on the evaluation metric. So the output from this would be clusters 3 to 9, and it would contain 2 different metrics, mean squared distance and Davies-Bode indexes. And Davies-Bode index essentially tells you how well the algorithm would perform. So the lower that number, the better the clustering is essentially performing. And to view all this table more easily, you can just call the evaluation metric and view it within BigQuery, and you can see the different Davies-Bode indexes in this case for a different number of clusters. If you look at this carefully, you will see that the number of clusters 7 is the one that performs the best of all the different number of clusters. And that's why we're using 7 within today's example. So in this example, we know we're going to use 7 as the number of clusters. So when you create a cluster, you would have to understand what kind of cluster you've created, what are the properties of these different clusters. So in this case, we would create a procedure called inspect clusters that allows you to look at the properties of these clusters and allow you to analyze it. And we will store this procedure called inspect clusters. And this will output you the centroid ID and how people behave. So in this example, it is possible to run all the different number of clusters, 3 to 9, but we know we're going to be working with 7. So within BigQuery, we're only going to run this on cluster number 7 and look at the output table at the end. The results we should be able to see. So we have 7 different centroids, and the number of users within each of these centroids, you can see them. And the average number of purchases, average volume of purchases that you have for each category and total product price, etc., you can see them, as well as the HHI. In this case, we wouldn't be looking at the average for HHI, but again, this is how the initial output looks like. Again, this is not the ideal way to look at this data, but now we're going to actually move on how to analyze this within Data Studio. Once we have these clusters, the next step is essentially creating predictions, right? Again, we can use the ML predict model to actually run the prediction on an existing data set. But again, as always, it is more useful to create these as certain procedures so you can run them across multiple data sets if you want to. But essentially, in this case, what we are doing is looking at the k-means within the training data set, leveraging the k-means 7 cluster. This routine would normally take any number of clusters, but we're going to use 7. And this will, at the end, create a completely new table using BQML k-means 7 classifications. If we look at the table, this is what it looks like. In this case, if we look at it, we can see each row has a different user ID and a different purchase they've made. They also have a centroid ID, which you can see different number of centroids, right? It is actually giving you the distance to each of the different centroid IDs. And the lowest number of this is essentially the centroid ID column. Once we have this in a table, we can export this data into other marketing analysis channels. In this case, we're going to use Data Studio. And Google Cloud makes it extremely easy to actually do this. While you're on an existing table, you can simply click Export and select Data Studio to immediately connect Data Studio to this specific table. And here you can create custom graphs and tables to analyze data in more detail. Here's a Data Studio dashboard that we've created using the data set from the BigQuery table. Essentially, the initial page gives you the overall analysis. And this page essentially contains all the information that you would have if you never actually leverage the audience segmentation analysis. If you look at here, this is all based on CRM data. Things like average sales by gender, total sales, household income distribution, the average basket sizes, as well as the customers by device type and average baskets split by different device types. Also total sales by devices. It's easy to analyze this data visually. But more importantly, if we look at the customer behavior by cluster, this is where we actually see the differences. Now we have 7 different clusters, and we can see cluster number 4 is actually the largest one. And cluster 2 and 7 are relatively small within this data set. But this is only the overview. We can also look at the different clusters and what they're purchasing in more detail. This will give us how all these clusters are behaving regarding the purchases they're making. On this page on the dashboard, we can see how all these clusters are making their purchasing decisions. The cluster 1 has a quite heavy accessory and apparel and electronics purchases. And here you can see the differences between the different clusters. So cluster 4 was the largest one. So if we quickly take a look at it, we can see that they're buying accessories the most. We can also identify some interesting clusters. Cluster 6, for example, is only purchasing apparels almost exclusively. Similarly, cluster 3 seems to be buying office supplies more than anything else. So this data can be used to optimize the marketing messages that we will send out to these customers. A quick and easy way to do this would be to use Data Studio. Again, this would not be something that we would recommend for large-scale use cases, but for smaller data sets, it's always possible to actually export these data. For example, in this case, we are actually going to target the people within the centroid 6, and you can export the full visitor ID using the export function and export the CSV file. You can also select different filters that are present on their web page. But if you want to automate this and really leverage the fully automated nature of Google Cloud Platform, tentacles would be the example that we're going to look at now. So we talked about tentacles a bit during the presentation. We talked about the 3 different modules that we're using that essentially look at the cloud storage bucket using cloud functions and pushing any new data through PubSub to the marketing channels. So once we have that, our trained data, predicted data, the next step is to create a pipeline within Tentacles to push this into the marketing channels. So we will create a new table to make sure it fits the format that we're going to export into. In this case, we're going to export into Google Analytics. So we're creating a new table called activation output and only extracting 3 different columns within this data. So we're taking the visitor ID, a Centroid ID, and we're also naming a certain different field called CD2. Essentially, this is what the activation output looks like. So customer ID, cluster ID, this is the cluster index number 2. This is something that's required from the Google Analytics side. Now, let's look at Google Analytics to make sure we actually do the right setup for the data to be ingested into Google Analytics properly now. On our Google Analytics website, the admin section from the properties settings, one important to note is that the tracking ID is something that we need to leverage into Tentacles. We also have to do a couple of setups. One of them is setting custom dimensions. In this case, we're using something called segment, and this is where we're pushing in the different segment IDs of the users. This would have to be created manually on the first go within Google Analytics. And the key thing is here in this example is that we're leveraging what is called index, and that's what we need to have within the column in the data set. And once we set this up, the name is essentially going to be segment and the dimension too, and the scope is going to be set at a user level. After we create this, we utilize this data within audience definitions. So if you go to audiences, you can create a new audience list based on this data. So if we look at the existing data segment that we have, segment 3, and this is what we have as a higher value product buyer, for example. So this is actually set up and the view is based on Tentacles test. So every time a data is uploaded with the segment condition equal to 3, this is the audience list the user is going to be based into. And this is how Google Analytics would be activating the data. So going back to the table that we had, we have the customer segments ready to be read by Tentacles. And here we would be exporting this data and we have to place it in a specific bucket and using a specific file name. So in this case, we're using MP, that refers to measurement protocol for Google Analytics, and it's using the default analytics settings. And the export file format needs to be JSON in this case. And once we save this, this data will be automatically saved into GCS bucket. And then Tentacles will identify it and push it directly into Google Analytics. And once the data is in Google Analytics, you should be able to say high value product buyer data within Google Analytics reports and analyze all the different audience lists. You can also sync Google Analytics to Google Ads to leverage the customer match functionality and custom audience functionality to leverage this in your marketing activation channels. So thank you, and this will be all for our demo for today.
Wow, that was a great demo, Jan.
Yeah, thank you, Ken. Likewise.
So I hope you have enjoyed the 2 demos. As a recap, before we close off, we have discussed how a CDP can be the solution to address some of the key challenges in the industry in terms of how first-party data should be collected and used. We have also shown you different building blocks on Google Cloud and the way they fit together to create an effective engine to power your marketing analytics objective.
We hope we have given you enough to get you started on your journey on how to ingest data from your marketing resources, how to create custom audience segments, and how to activate them on your marketing channels. Here are some additional resources that might be useful for further learning. We will share these with you in the follow-up email, which you should receive within the next few days.
Now, to the right of the screen, there is a feedback form. Please share with us how we can make the next event better for you.
That's all from us today. Reach out to us if you'd like to learn more about these topics that we covered. Goodbye.
Bye for now.